Hi, this is Bharat Jadhav, and today I'll be talking about deep learning with Microsoft Cognitive Toolkit or CNTK. And we're trying to develop an application which will predict whether a flight is going to be on time or whether it will be delayed based on its past performance. And to do this, we're going to be using Microsoft Cognitive Toolkit along with Python version 3.6.3. And I'm using the Anaconda platform to develop in Python just because it's so convenient using Jupyter Notebook, and the packages that I'm using are Pandas, data frames, NumPy, SciPy, Matplotlib. And I also used TextPad to manipulate some of the data that I had downloaded. So the data set that we're using is all flight information from 2015. Now this data is maintained and published by the US Department of Transportation, and I downloaded it from the Kaggle competition website. So the size of the file was about 564 MB, and I reduced it to about 6 MB. For the sake of this application, I restricted the data to just flights operated by Delta in the month of January 2015. These are the installation links for all the softwares that I used. The installation of all of these is fairly straightforward. Um, so I'll briefly walk through the crux of the application. I in Python I had to set up the environment, load the data, trim it down to the columns that I wanted, split the data into features and labels. Um, Declare my or define my network with the number of layers and the number of nodes per layer. Also set the learning rate and the batch size. Then I split the data into a 80-20 ratio. And given the size of my data, I ended up with about 51,000 records for uh, training the model and about 12,700 records for testing, which is a decent size. Um, and like I said, I created the training model over here, created a couple of utility functions to capture the metrics, set the learning rate to 0.01. Um, and based on the data, if I set the data size, if I set the batch size to 100, I ended up with about 510 batches, which means about 510 epochs for the application, which is a decent number. And this is the result I got. I started with a loss of 0.63, and I ended up with it dropped down to 0.24, and the training error started with 0.3, and it dropped down to 0.06 by the time the network was trained. These graphs show the loss and the error as the network trained. Um, Let me walk over to the demonstration. So I'll run the application. Um, There I'm setting up the environment and reading the data into a pandas data frame. So I can see I have about 64,000 records over here. These are the columns that are in the data set, and I really don't need all this information for my network. So I'm going to trim out all the extra columns from there because I really am interested only in the flight number, the origin airport, and the departure time. Now I could make it more complex by taking into account the arrival airport, or whether the flight was delayed upon arrival as well. But for now, I'm sticking to a basic model. Um, and then I just display this information. Now I look for any missing values in my data set, and there are about 669 that don't have any departure information, so I clean those out. Um, and now I'm going to prepare my data for the network. So we're using a feed forward network, which is basically a classifier. So we're going to classify whether a flight is on time or it's going to be delayed. So to do that, I'm going to add two columns, on time and is delayed, and these I populated these based on the value in the departure column. So now this is the data set that we'll use to train our network, and flight number and the airport will be our features, and on time and is delayed will be our labels. But the airport being a categorical data, I'll have to use one hot encoding to represent the airports, and so I assign integer values to the airport, and then I create the one hot encoding values for the airport, and create the features and the labels. So the labels was the simple part because it's just these two columns, and then I split the data 80% for training and 20% for testing, and I end up with about 51,000 records for training with 146 features, and 12,700 records for testing. To see how our features look like, this is how they look, and most of this data is just the airports, and this is the delay. Um, Now I define my network. I declared two hidden layers with 40 nodes for each layer, and the number of output classes is 2 because we're going to classify it whether it's on time or it's delayed. And then I create the training model, and this is the beauty of Microsoft Cognitive Toolkit, which these to create these models was very intuitive, and they even have a sequential function where you can invoke the layers using lambda expressions. Um, so let's run this. Oh, yeah, because I didn't run this. All right, so now our training model is created, and here we store the loss and the error, and here I declare the parameters for the trainer object. I set the learning rate to 0.01 and use the stochastic gradient descent um, optimizer, and declare the trainer. Um, and here are utility functions to plot graphs while our network is being trained. And here I'm setting the batch size to 100, and based on the data we end up with about 510 mini batches, and each batch will be one epoch. So we're going to train the network to about 510 epochs, and this is where I run the network, and we can see that the first batch starts with a training loss of 0.63, and the training error starts with 0.306, and I paused the recording while the network was training, or the model was training, and it's just about to complete training. So we can see that It's coming along nicely. The training loss started at 0.63 and now it ended at 0.239. The training error was 0.30 in the beginning and set about 0.06, which are very respectable numbers. And now let's plot a graph based on our training, and this shows the loss and the error, and both improve or drop significantly as the network more progresses. Now we test our model, and the error comes out to 0.069, which is in line with what we got for training as well. And these are the actual labels versus the predicted labels. And if we look at them, they're fairly accurate. So this was a very interesting experience to research the CNTK, as it's a relatively new player in the deep learning arena, and it has very limited development community. So there aren't a lot of examples on Stack Overflow or other websites, though Microsoft and GitHub have a good number of tutorials on CNTK, and it does offer the Python APIs it offers are very user friendly and intuitive compared to, say, TensorFlow. Now, a few people do say that CNTK is much faster than its peers, but I don't know. I haven't seen any quantitative data to support that. Also, there's not much support for the Microsoft languages such as C++ or C Sharp. There are a few examples out there, or a few things you can do using C++ and C Sharp, but the majority of the support is for Python. Now, when I started creating this model, I also realized that I could have made it much more complex. Now, if I had taken I only based my model on the aircraft number and the airport of origin and the departure delay, but I could have included, say, the arrival if the flight was delayed on arrival as well, or it made up for the delay in flight, and considering the arrival airport and whatnot. So the parameters, the complexity of the network increases as we increase the parameters, but that's something that I can look into building up on this project. Also, the only two learning functions I experimented were the sigmoid and tanh functions, which are the most common ones. I didn't try to venture out too much with the functions I was using to train my network. But I hope you enjoyed this short presentation. I know I thoroughly enjoyed exploring Microsoft CNTK. Thank you.